Next up is Martin Kleppman, and I'm so excited to have him back because actually I have seen his presentation 3 years ago, also at Craft in a tent. He's going to talk about Automerge, the same technology he talked about 3 years ago, but first of all, a lot of time has passed, and I hear he's back with exciting news. And also, today he's going to focus on the computer science research that makes this technology possible. Martin, the stage is yours.
Thank you very much. It's exciting to be back at Craft. I've spoken a few times already, so back virtually. Yes, I would like to talk about Automerge. My name is Martin Kleppman. You might know me from this book that I published a couple of years ago called Designing Data-Intensive Applications. You can find it at dataintensive.net if you're interested. Thank you also to the people who fund my work and who make this possible, including I have a Patreon where people support me on a crowdfunding basis. You can find the URL there on the slide. If you're interested, you can join them. But let me talk about the actual substance of things. And so let me go back to the history of how we built web apps. And so maybe 10 years ago, 15 years ago, if you built a web app, it would look something like this. You would have a server written in your favorite server-based programming language, which would return some HTML to a web browser, and you could click some buttons in the web browser to submit some forms, which would go back to the server, and it would store its data in a database. Simple enough. Now, that wasn't good enough for us, so we added some JavaScript in the process. So we now have some JavaScript typically running client-side in the web browser, which talks to the server, possibly via REST API. Maybe there's still some HTML involved. But key difference is now we have this code running on the client side as well. And that has a lot of advantages because we can now build apps that respond more quickly to user input. We can have nicer interaction without having to reload the entire page on every single interaction. But it has also introduced a lot of complexity. So let's think a little bit about what happens to the data as it travels through these various layers. So you want to display some data in a web browser, so you use the HTML DOM to display something, and typically if you're using a client-side app, you've got some kind of rendering mechanism. So you've got some state that is kept in JavaScript objects on the client side, and that gets rendered into HTML, perhaps using something like React. Now, where does that state come from? Well, it probably comes from a REST API from a server. So you also have to hook up this JavaScript state to some kind of mechanism for making HTTP requests to the server. On the server side, well, on the server side, you're responding with this JSON. That doesn't just come from anywhere. Typically, that also comes from some model objects. This is model in the sense of model view controller on the server side. So you're converting the data in these model objects into JSON, which gets returned to the JavaScript and so on. But that's not all, because typically you will also want to store that data in a database, maybe in a SQL database. So maybe you have an object relational mapper, which takes this object and persists them in a relational database. Of course, that database is itself serializing the data to disk in some internal storage format that it's using. And so if you think about it, this is complete madness because we've got 6 different representations of the same data. And all we're doing in most of our application code is just taking data from one representation and converting it into another representation and just pushing it through these various stages. There's a huge amount of complexity here that is really kind of unnecessary because all it's doing is just converting between different representations. Moreover, there are other problems in this web app paradigm. So that is, think about the timing of what happens when a user clicks a button in their web browser. You've got some JavaScript code, the event handler which handles that click event, and, well, it has to probably update some data on the server. So it makes an HTTP request to a backend server. The backend server handles that. It has some code which handles that, which may make some database queries to look up some data, store some data, and so on. And while all of this is happening, what is the web browser doing? Well, the app in the web browser is probably just showing a spinner. And it's going round and round and round, spinning, 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 while all of this communication is taking place. And at some point, then the response comes back from the server. We get a callback on the client side, and we can update the user interface to say, OK, yes, we have successfully stored that data on the server. Now, this is clearly pretty terrible because the round trip time might mean a long wait with a lot of spinning. So people came up with this genius idea that maybe we actually update the user interface immediately. We update immediately to say, okay, without actually waiting for the round trip to the server to complete, we're just going to update the user interface immediately to say, okay, and we call this optimistic UI. And it's brilliant because it now hides all of the server communication latency from our users. Except we now have a different problem, which is, well, think about what happens here. The user clicked the button, we called the event handler, we made a HTTP request to a server, and we immediately updated the user interface. And then maybe you're on an unreliable network. Maybe you're in a coffee shop and the Wi-Fi has let you down. Maybe the server the request that we made to the server never actually got through because of the network. And as a result, nothing happened. Eventually a timeout happens, and we get an error call back on the client side, and now we have to update the user interface. The user interface previously said, tick, okay, everything is fine, but now we have to update it to say, actually, no, sorry, it wasn't fine after all. We changed our mind because we only found out sometime later that now this updated user interface wasn't actually correct. Okay, this is kind of a mess. We have proposed a new way of thinking about collaboration software that we think helps solve some of these problems. And we called this local first software. You can find details on it at this URL. We wrote a whole article on what we think about what we mean with local first software. The basic idea is that we change the responsibilities between the server and the client. So in the traditional web app model, the server has the primary storage of all data, which means that if you want some data to be persisted, it has to go in the server's database, otherwise it basically didn't happen. Any client-side state is treated as ephemeral, is treated as disposable. The user might reload their browser tab at any moment and lose any state on the client. So anything that has to be stored has to go on the server. In the local first model, we change this around and we say, actually, on the client side, we do have storage on our local device. How about we treat that local storage on the user's device as the primary copy of the data? The server still has a copy of the data, but it's only a secondary copy that assists with syncing between the data between different devices. And the great thing about storing data on your local device is it always works, because even if you're offline, you can always access your local storage. And it doesn't matter if you're online or offline, and it's always fast as well, because you don't have to wait for a network round trip. So in the local first model, if the user clicks the button, we call the event handler, we update the data locally, we store it immediately in the user's local storage, and we can update the user interface. And this time, there's no going back, because this is the primary storage. The synchronization of the data with the server can happen at some later point in time. So there can be a background process now which syncs these data updates with a server and with other clients, but the user interface doesn't need to wait for this. And so this is great in terms of performance, but it's also great in terms of reducing the complexity, because if you think about these 6 different representations, in the local first model, we can reduce this down to half. We can reduce it down to 3 different representations. We've still got the HTML DOM, we've still got the JavaScript application state, but we now use a syncing engine to store that state on the local storage on the client, and to sync it with the server and with any other clients. So you've got this beautifully self-contained app, which is essentially just the client-side code, and we've simply got rid of most of the server-side complexity. There is still a server, but the server is a generic piece of code. It's like an HTTP server. You don't write a new HTTP server from scratch for every app that you build. You just use an off-the-shelf open source HTTP server like everybody else. And likewise, the syncing infrastructure, data sync infrastructure for local first software can also be equally generic. You don't have to write new syncing infrastructure for every single app that you build. We can write that logic once, get it right, and then have that shared by any app. On the client side, well, we've reduced the complexity a lot, as I said. We have no optimistic UI. We can just update the UI immediately. There are no spinners, no error callbacks to deal with, and so on. However, what it means is now you can have several users updating data independently from each other while they're both offline. And if the users are both offline, well, they'll only find out sometime later that somebody else also modified that data. And so that is now the key problem that we have to handle, is what about several users updating data at the same time? And this is where Automerge comes in. So this is an open source library in JavaScript that I've been working on for a couple of years. We now also have a Rust implementation, and we're making it available for various other programming languages. And Automerge essentially gives you a JSON-like data model which you can update. So say you want to make a to-do list, you might represent the state of that to-do list in a JSON-like representation like this. You've got a list of to-do items. Each to-do item consists of a string describing the to-do item and a done field, which is a Boolean, indicated whether you've checked the box for that item, whether it's done or not. Okay, and so you can manage this state using Automerge. And if you want to change it, if you want to make any sort of change to the state, you call the automerge.change function. And in this case, you will update the item number 1 and change it to do its done field from false to true. Now, Automerge is structured in a certain way that allows us to perform this kind of storage and syncing that I talked about earlier. And so one aspect is that, first of all, we treat the application state as an immutable object. And so you pass in the existing state and you get back a new object containing the updated state. You can also attach a descriptive text describing what change was made. This is optional, you can leave it out, but think of it like a commit message in Git. It just allows you to attach a bit of metadata to a change to describe what the change was. And then within this callback, we now have access to a mutable version of the document where we can change any property of the document, and Automerge will record exactly what was changed. So what you can also do, apart from updating an individual field, is, for example, you could add a new item to the to-do list. And here we can call doc.todos.push, which is just the JavaScript function for appending an item to an array. And it will do exactly what you wanted. It will add the item do laundry as the third item in this array now. Okay, so this is the simple case where just one user is updating the data at any one time. Now let's think a bit about different versions coexisting. So maybe different users are updating this document concurrently. Maybe those users are offline. And what we can do is we can have a kind of branching and merging workflow very much like Git. So think about this like Git, where the state, rather than being a repository of your code, the state is the state of your application. And so the to-do list on one branch gets updated to set the watering plants item done to true. And concurrently, a different user is updating it to add do laundry as a third item. And what we want to now do is to merge those concurrent changes together back into a consistent state in which all of those changes are reflected. So in which watering the plants is done is set to true, and in which do laundry exists. So we want to be able to take those concurrent changes, move them back into a consistent state. And this is precisely what Automerge does. The name comes from automatically merging. And the properties that Automerge guarantees here are, firstly, that if you have several changes made, we preserve all of those changes. Secondly, if two users observe the same set of updates, so they've each made some updates, but then they perform the sync protocol and they end up seeing all the same updates, then they always converge to the same state. And finally, we can have arbitrary branching and merging workflows in the editing history or the update history of this state, and any branches can always be merged cleanly. And so unlike Git, where you have to deal with merge conflicts potentially, Automerge is built in a way that conflicts can always be merged in a sensible way. And we will see in a moment what sensible means exactly. But it means like we can have these arbitrary branching workflows. We could have different versions side by side. We can compare them. We can compare versions over time as well and see how the document changed over time. And all of this is possible because Automerge is what we call a CRDT, a conflict-free replicated data type. So this is a group of a family of algorithms that have been developed in computer science research over the last 10, 15 years or so. And Automerge implements a bunch of these CRDT algorithms in order to perform this merging. So let me show you a little bit about how this actually works internally. When you call Automerge.change and you perform some mutation, Automerge has to somehow record what exactly those changes were so that it can send it over the network to anyone else who also has a copy of this data. And so when you insert this new item, do laundry, into the to-do list, this breaks down into a sequence of operations. And the operations are like the most fine-grained representation of the change that you can imagine. And so this particular example here will break down into 3 individual operations. A first operation which creates a new empty map object. So map here being a map from keys to values. So in this case, the keys are title and done. The values are do laundry and false. We make a new map. We insert it into the to-do item list. That is the first operation. The second operation sets the title key within this new map to do laundry. And the third operation sets the done field to false. Okay. And so that way we have performed the changes necessary to perform this list insertion. And now Automerge, for the purposes of network communication and storage, it will actually take these operations and represent them in a compact binary way. So Automerge has its own binary encoding format. So it turns those changes into a byte array, and that byte array can be written to disk. It can be sent over the network. It can be stored on a server, and so on. You can do anything you like with the byte array. It's just a compact representation of these changes. So let's look at a bit more exactly what happens when we have updates happening. So here we have the example we just saw of watering the plants. And now let's say we want to update the done field from false to true. And so what happens here is that firstly, each object in the Automerge document is given a unique ID, and that allows us to tell exactly which object within this JSON document we're talking to. Because otherwise, if we say the object at index 5, well, index 5 might change because somebody else might insert or delete something in front of it. So instead, we use these unique IDs, which I've just made them a number and a letter. Internally, they're a bit more complex. But the idea is the same. So we've got an ID that is created when the map object is created, and then any later operations reference the ID of that object. Secondly, when a field is updated, then, well, each assignment operation has an ID. And in this case, the initial assignment operation that set the done field to false, that operation had an ID of 3A. And then when we later come to update the value for the done field and want to set it to true, we have this overwrites information, which tells us, the value of true overwrites the prior value that was set by the operation with ID 3A. And so this now tells Automerge, okay, the value true overwrites the value false. So the value false is no longer there. Now the new value is true. And this makes very clear exactly what is happening if we have several users concurrently updating the document. So imagine we add a deadline feature to this to-do list, where you can set a date by which some to-do item needs to be done. And you have 2 different users who set the deadline for the same to-do items to 2 different dates. In this case, what can we do? There's no automatic merging we can do because they're simply 2 different dates. They're in conflict with each other fundamentally. So what we can do here is, well, every time that the deadline is assigned in an assignment operation, we, again, like previously, record the fact of which operation overwrites which previous operation. And in this case, you can see here we've got the 2 different values, the 10th and the 14th of July, but the overwrites field is empty in both cases. And from this information, we can tell that, neither of these 2 deadline setting operations overwrites the other one, which means that since neither overwrites the other one, the 2 must be independent from each other. The 2 must be concurrent. And in this case, we just keep both of the values. In this case, there's nothing clever that Automerge can do, really, because we don't know the meaning of this string. Automerge just takes this date here as being a string. And in this case, we have to keep both of the values and maybe let the user choose which one they actually wanted, or maybe there's some kind of automatic application level conflict resolution that you can do. But this is really the only case in which the application needs to get involved in conflict resolution. So the only case where this happens is when you have several users concurrently updating the same property of the same object. Any other kind of changes can be handled automatically. And so just to give you an idea of what changes those are, since we have a JSON data model with a couple of extensions, and the operations are, well, creating a map, updating a map, deleting a key from a map. in a list, inserting or deleting items. We can have counters, we can have inserting and deleting text, and so on. So all of these things can be handled automatically. And this allows us to build rich collaborative applications across a kind of spectrum of how real-time you want to be. So in the super real-time Google Docs style, see immediately what somebody else is typing character by character, you can build that sort of real-time collaboration. Or at the other extreme, you could build a sort of pull request-like collaboration where you accumulate a large set of changes, and when the user is ready, they present those changes to the other users, and somebody else can choose whether to merge it in or not. And you can have various intermediate levels of granularity where maybe you have Google Docs style suggesting changes, which is not as heavyweight as a pull request, but it's still a bit more asynchronous than sort of real-time character by character, keystroke by keystroke editing. Now, I want to talk about one really interesting thing here, which is what happens when other users make changes to a document. And so we've got here this kind of flow where the Automerge document is your client-side state, maintaining the state of the document. You use something like React to update the user interface. Whenever somebody interacts with that in some way, you have an event handler which updates the Automerge document, and as a result, the Automerge document then gets rendered back into the user interface. And so this is like the typical React way of building apps. The really nice thing is now that because the state is managed by Automerge, we can just write it to disk, and we can sync it with other nodes, we can sync it with servers. And all of that synchronization infrastructure is generic, as I said before. Moreover, we can have other users which also make changes and which are also synced with the server. And so let's say, for example, another user performs this update, setting the done field to true. In that case, that update, that change, will get synced to the server. It'll get synced to our local copy of the document. And all we need to do then is re-render the user interface using the existing React mechanism for rendering the user interface. So we've gained the ability to merge in changes from other users without writing any additional code at all. We've just written the typical functional reactive programming style loop for taking some state, rendering it into a user interface, and updating the user interface whenever the state changes. But now this also means that whenever the state changes because a different user changed it, well, we just do exactly the same to update our user interface. So we get real-time updates in collaboration with absolutely minimal effort, which is wonderful from the point of view of keeping complexity small. A nice thing with Automerge is also that synchronization can work through many different types of network protocol. So you can have typical client-server sync as you would typically have with a web app, and that is totally fine. But you could also have multiple servers and have some kind of federated setup, or you can even go peer-to-peer and you can synchronize data directly between users. And all of these are fine. Automerge doesn't care how you get the changes from one user to another. All it does is like say, here's a byte array. Can you just make sure that everyone who has a copy of this document also gets a copy of that byte array, please? And as long as your network protocol can do that, it's able to bring all of these users in sync with each other. A few words on the implementation. So Automerge started as a JavaScript library, and we broke it up into what we call a front end and a back end. Don't think of this, though, as back end being server, front end being client. This is not what we mean here. So front end and back end are both in the same process. They're both client-side code. We just separate them from a code structure point of view. And one nice thing we can do here is we have also implemented the backend in Rust, and we can compile it to WebAssembly, and we can then access it through exactly the same JavaScript API as we have with the JavaScript backend. So we get better performance from being able to use Rust and WebAssembly while still having a nice expressive JavaScript API. And the front-end backend protocol gives us the communication interface between the Rust world and the JavaScript world. But the nice thing now about having a Rust implementation is we can also access that from various other programming languages. So for example, we can use it from Python. We have C bindings, which allow us to have a Swift wrapper around it. Of course, we can also have a Rust API on top of this. And our plan is to extend this basically to all popular programming languages. The Rust implementation will hopefully be our primary one so that you can use it on any platform. You don't need a JavaScript runtime. And the Rust is wonderful from the point of view of producing cross-platform, highly efficient code. On top of all of this, you can then build multi-platform apps that run everywhere where you can compile this stuff, essentially. The storage and networking layer is deliberately kept separate from Automerge, because if you're running in a web browser, the APIs you have for storage are different from if you're running in Node.js in a server and you can access the file system, for example. So that's why the I/O, the storage, networking are kept separate. But Automerge provides these high-level APIs which allow you to quite easily link it up to any network protocol or any storage system that you want. Let me say a little bit about how the storage works. Because as you're editing a document, so let's say you're typing a text document and you're typing hello one letter at a time, you can imagine that this becomes quite a long list of updates fairly quickly. And if we just store each of these keystrokes individually, this can get quite large. And so what we also have is a kind of compaction mechanism, which still keeps all of the editing history, but it takes all of that down and compresses it into a small, compact representation of the document. Think of it like a snapshot, almost. And so we can just do this periodically. So when the log gets too long, define too long in some application-specific way, we can just say, OK, now we're going to take the accumulated log and crush it down, compress it down into a snapshot. And then on top of that log, you can just keep adding changes one after another, again, just as byte arrays. And then once that gets too long, again, you just compress it down into a snapshot. And that way you can have a document saying hello world here, for example. A few words on how this kind of encoding and snapshot compression performs. So we've been testing this stuff with a text editing benchmark, which consists of mainly me hacking away at a document. It's actually a scientific paper, a research paper that we published, and we recorded every single keystroke that went into the editing of that paper. And so we are now using that as a test data set, essentially. And it's got about 360,000 keystrokes in the full editing history of that document. And if we represent that as a log of individual changes in Automerge, each change is round about 100 bytes once you include all of the metadata and stuff. So it's about 36 megabytes to represent this entire editing history as individual changes. But with the snapshot compression that we developed, we can compress this down to about 300 kilobytes. So 2 orders of magnitude more compact, requiring only less than 1 byte per change. And the cool thing with this is that it's still got the full editing history in there. So you can still do all of the branching, merging, comparing different versions. You can still see what the document was like 3 days ago. All of that information is still there, but just represented in a much more compact way, which is really nice. So the status of Automerge right now is that we are in the process of releasing a 1.0 version. So we've already got a 1.0 preview release out now. And the idea of that is the data format is now stable. You can start relying on the APIs as being stable, but there's still a few little bits and pieces missing that we are still finishing off. But essentially, we're getting pretty close to a 1.0 version. That is for both the JavaScript and the Rust implementation. The JavaScript implementation is a bit better tested, but the Rust implementation is faster. So hopefully over time, the Rust implementation will become the primary one. We've got several users experimenting with this and some users using it in production. So it's definitely still an early stage project. I'm not going to say it's super mature. In particular, the performance needs more work, and that is something that I'm actively working on at the moment. But it's definitely getting there. We've got a huge long to-do list of 1 million features that we want to add over time, and I've mentioned some of them on the slide. I'm not going to read them all out. So there's, it's still a long path to go, but I think the foundations I'm really happy with now, where we've been able to get this. So that is essentially what I want to say about Automerge. So I believe that this local first way of building software is very promising because it allows us to build collaborative apps in a way that is radically simpler than the existing typical web app way where you have 6 different representations of the data. Because the server is essentially just a generic piece of infrastructure, and you don't need to write any or maybe very little server code. You might have a little bit of authentication or something like that, which might be application specific. But apart from that, it's all super generic stuff. And so we have now moved a lot of the complexity into Automerge and down into the infrastructure so that the applications can be simpler. Moreover, the applications can be more reliable and more resilient because a bunch of reasons. Well, first of all, the client software just works offline. So it doesn't care whether you're online or offline because you're just storing data locally and then you're syncing it whenever a network connection is available. It also makes it much easier if you want to move from one cloud provider to another because it's just a generic server. Whether you sync with this server or that server or with two different servers in parallel makes very little difference. Because there's no particular network topology, there's no consensus protocol in here or anything like that. All we're doing is just making sure that the bytes somehow get from one client to the other. It's even compatible with using end-to-end encryption. So you can potentially have only encrypted data ever stored on the servers, and only the clients see the unencrypted data. So from a security point of view, that is also very interesting. But finally, and maybe most importantly, there's the potential for a better user experience because you don't have this spinner when the user clicks a button and waiting for a round trip to the server, because the software can just immediately respond even while it's offline or even if you're on an unreliable coffee shop Wi-Fi. We get still this kind of Google Docs style real-time collaboration and data synchronization, but at the same time, because the users locally have a copy of the data on their own device, they own that data. Nobody can take it away from you. And I think that's a very powerful thing in terms of empowering users and making software better. If you want to read more about it, there's plenty here. So you can look at the open source repo for Automerge. You can read the article on local first software. Obviously, you can contact me with any questions as well. But I believe we have a bit of time for questions now as well. So I look forward to hearing those. Thank you very much.
Thank you, Martin. You got me at no consensus protocol. Those are always so hard. Everyone.
Nothing wrong with consensus protocols, but they are a bit of a nightmare sometimes.
Yeah, bit of a nightmare. Nicely put. Everyone, please go to the Q&A tab and put all your questions there. Remember, there's a potential price in it, but I see there are already many questions, and I'm pretty sure everyone has a lot of questions. And while you're there, don't forget to rate Martin's talk in the polls tab also. While we are waiting for some more questions to appear, Martin, let me ask you, can you do some name dropping? Are there any companies we might have heard of that are, you said, experimenting with this already or maybe sponsoring this project?
Yeah, we don't have any corporate sponsors yet. So at the moment, all the sponsors are essentially people privately interested in it. We are considering whether there should be some kind of proper organization behind this, but we haven't decided on yet what exactly that should be. In terms of people using this in production, I don't know how much is publicly known, but there are certainly some startups using it for documentation purposes, for example. One very interesting user is the Washington Post, who are using this. I believe this is now live. Actually, they're using it for the updating of their homepage. So they have several editors who collaborate on deciding what is the layout of the homepage, which article goes where, what is the headline of each article, what picture is used, and so on. And those updates are being done through Automerge because they are using this kind of branching and merging workflow where one editor may suggest some changes to the homepage, and then another one can decide to actually click the button to publish it to the live version. So to be clear, this is an editorial tool. It's, if you go to the Washington Post homepage yourself, you're just seeing HTML. There's no Automerge there. It's just the collaboration between the editors who are working on the layout for the homepage.
Yeah, but still, it's a very good use case. Let's go to the Q&A. The most popular question is, do you have support for undoing operations? Nándor, előtt fekete ez this.
Yes. So we used to have support for undo, and we actually removed it again in 1.0 because the previous implementation was a bit of a hack, and I was not really happy with that. It's definitely coming back, though. So I think undo is super important here. The important thing is getting the details right. So if you've got several users updating a document, for example, you want to make sure that undo behaves in the way you want. And from what we've figured out from our user studies so far, what you want in most apps means you undo your own most recent local change. Even if somebody else has made a change in the meantime, you don't actually want to undo the other user change, you want to undo your own change. At least that's what happens if you press Control Z. Typically there you're expecting your own change to be undone. However, there probably also needs to be some way of reverting other people's change. And so I'm using revert here as a separate word from undo, just to indicate that they're kind of two different things, even though both are a way of essentially moving back to a prior state of the document. So yes, previously we had a simple version of undo that did only your own local changes, but we are going to bring that back in a more extensive form with proper support for both undo and revert.
Yeah, it's always really hard to figure out what is exactly the behavior that the user wants under the term undo. The next question is from Sebastian Boulet. Does it mean that business rules have to be implemented on client side?
Yes, absolutely. So it's you can have server-side validation of data, of course, and one simple way of doing that is actually to run a headless version of Automerge on the server, because it's just a data structure library. There's no user interface dependency on it, and it works in Node.js just as well as in the browser. So you can, for example, have the server take some change that is received from a client, apply it to its own copy of the data, check whether that state is allowed, or even check the mutations made by that change, and then decide whether to accept it or not. And you can certainly do that if you want. Of course, if you're going to use any sort of peer-to-peer synchronization, then you have to do the any checks client side. So if you're going to use peer-to-peer, there is no server that can perform this kind of validation for you. And in that case, the model that we're using is, you can if you've got some data, you can change it in any way, and nobody can stop you from changing it. Similarly, if you have your own copy of the constitution of your country, you might scribble on your copy of the constitution, but that doesn't make it legally valid. You've just updated your own copy of it. And so what matters is, do other people pay attention to your changes or not? And so what you can have is validation of any business rules in terms of, for example, who's allowed to change what. And you do that validation when you receive the changes from other users. And that is then consistent with this local first idea that your own local storage is the primary copy of the data. And the client can validate it in just the same way as a server would validate it. You can have each client independently perform this validation, and the result should be correct.
Thank you. Excellent metaphor. Sebastian Goretsky asks, does it mean that in a couple of years we'll all be coding only on the client side?
I think servers will continue to exist, but I would hope that a lot of the focus of application development is moved to the client side and away from the servers. Because I think the server is simply a bad place to do that kind of development. Like, all of the user interface, all of the interaction, all of that is happening client side. The server should be taking care of infrastructure stuff, like making sure the data is stored, making sure that the backups work, making sure that the right bytes flow between the right users so that you have real-time synchronization and so on. But all of that sort of data synchronization stuff and storage stuff is generic. You don't have to write it on a per application basis. So I think most of the application-specific business logic can and should live client-side. And for the server side, to be honest, if Amazon Web Services decides they're going to bring out a data sync product for Automerge-based local first applications, that would be brilliant. We can pay them, 6 cents a month or something like that to do all of the data synchronization for us, and we don't care how it's implemented. That's somebody else's problem.
That's excellent. We have 2 more questions. One is then by Balázs Körösi Kyle. He asks, so do you solve persistence by adding database as a client?
Sorry, I didn't quite catch
Do
the
you
question.
solve persistence by adding the database as a client?
Soft persistence, was it?
Persistence.
Right. Yes, you can treat like a cloud side database as essentially one of the peers, and so using the data synchronization protocol between clients and servers, and the server just participates as a in the sync protocol in the same way as any client does, and whenever the server receives some data, it persists that in its database. This is very useful, especially if you have a peer-to-peer setting. You can't necessarily rely on peers being online at the same time. And if two peers are not online at the same time, they won't be able to directly communicate with each other. So a server then can provide not just the persistence, but also this kind of time shifting, so that one node can upload the changes when it's online. And sometime later, a different node comes online and it downloads whatever's happened while it was offline. But yes, I think it's worth rethinking exactly what persistence means and what the relationships between these components is.
Yeah, these are questions leading to very big architectural considerations. The last question is from John Nestoriak, and he asks, is this library or technique extensible to distributing data in a microservice architecture?
I would think probably yes. So Automerge is currently designed for a particular type of application, and that is the type of software where a user has a bunch of data and they can edit that data, essentially. And that might be a text document, it might be a spreadsheet, it might be graphics, some kind of vector graphics, or it might be some kind of 3D graphics like computer-aided design. It might be architectural plans for a building. Those types of things where you would think of the data as like a file in some sense, and where you could take the file and email it to somebody else, and then they have a copy of that data as well. And in that type of software, it makes sense to use an Automerge-like approach, because in some sense, all you're doing is the automation of this emailing files back and forth. Now, there's a different class of software which has different characteristics, and that is if you have an online store where there's a certain number of items available and you want to keep track of how many items have been sold, or if you're selling seats in a theater and you want to only sell a certain seat once, you don't want two people sitting on the same seat, or the same thing for seats in an aeroplane. Or if it's a ride-sharing service and you can have a certain maximum number of people sharing the same vehicle, those types of things don't really work well for an Automerge world, because you've got all of this logic that has to be centralized really in order to do the decision making of, do you still have an item in stock? Is this seat still available? Is there still a seat in this car? And so on. So for those types of applications, I don't think it makes sense to use Automerge. Really, I think traditional, what people are doing currently with microservices is fine. I would suggest maybe actually looking at stream processing as a way of supporting those kind of applications. But those are really software that lives very much in the data center on the server side. So I think there it makes very little sense to try and move it client side. But for the type of software which is like a user editing a file, like we discussed there, I think it does make a lot of sense to move all of the business logic client side. And then you don't really need microservices anymore, because all you've got is this generic sync infrastructure.
Yeah, thank you. I think it really makes sense. It's not a good practice if every client has a full copy of your relational database. That is not a very...
Yeah, exactly. Like if you have an online shop, you probably don't want the client to have to download the entire product catalog to their device, for example.
That absolutely makes sense.
And you certainly don't want to be downloading all of the purchases made by all of the other customers. That wouldn't make any sense.
That would be a GDPR nightmare.
Yes.
Thank you, Martin, for this presentation. Again, thank you for answering all our questions. As a token of our appreciation, we have prepared a little something for you that I hope with my colleagues here we can show the picture of.
Oh, that's cute. Thank you very much.
And
I have a similar mug from Craft 3 years ago, so it can go in my
Or
collection.
you can make a collection. We are going to send it to you, provided you have given your address to us.